Good afternoon, everyone. I'm Saurabh Kumar, software engineer from GeekyAnts. In today's meetup, I'll be talking about the React Native new architecture, which is in place and making buzz all around the world. The talk will be more like a technical analysis where we will be doing the comparison between the old architecture and the new architecture on basis of several parameters such as app storage, app load, and app build time. Also, at the end, we'll be discussing on some key highlights like lazy loading of turbo modules, how we can create our own custom turbo modules, and the next generation view manager, which is called as Fabric, which is only possible with this new architecture which is in place. So yeah, let's get started. So the setup for building any application, React Native application with this new architecture is very simple. Just we have to enable this new architecture. If we are going with the iOS build, inside the iOS folder, we have to run this rct new arc enable equals to one wala command. And for Android, it is even more simpler. You have to just go to the Android folder, and inside that you will just locate this gradle.properties file. And at the very bottom, you can see this uh, boolean property which is named as new arc enabled property. By default it is set to false. Just toggle it to true so that you can use the advantages with this new architecture, because it auto enables turbo modules on Android and iOS, and it auto enables Fabric on iOS and Android by enabling these boolean flags. I want to highlight one point is that if we are going with the latest React Native builds, latest versions, then we have to enable this property, and the auto enabling of turbo modules and Fabric will be done automatically. But if we are going with the older build, let's say 0.68 or so, we might have to update the Gradle version. Also, we might have to manually enable the turbo modules and Fabric on both Android and iOS, which is a kind of complicated thing. So with the new architecture, it is very simple. We just have to enable this thing. So while drawing the comparison between the old architecture and the new architecture, it is very straightforward and very simple. Just we have to enable this boolean field. Yeah. Next, coming on to the analysis, the parameter over here is build time. For building a very simple application with the old architecture, the build time is comparatively low as compared to the new architecture. It takes around 2 minutes and 23 seconds, as you can see. But with the new architecture in place, building the same application, the build time is usually longer, and this time is due to the compiling of some native C++ code. It roughly takes around 43 minutes and 34 seconds. So here we can see a big difference in numbers between the old architecture and the new architecture. As we'll go by the official documentation, we can run this yarn React Native run Android with added argument like active arc only. So it will ensure that your build time will reduce by a factor of 75% approximately. So we can go with this command. And it is still in experimental phase, so that by the next stable versions we can decrease this build time to somewhere around it matches with the old architecture. So that's all about this build time analysis. So next, coming on to the storage analysis. So for building a very simple application, the app storage is comparatively less in old architecture. Like it takes around 75 MB. But building the same application with this new architecture in place, the app storage is very high. Like it takes around 106 MB. So the storage is also very high for this new architecture. Now coming on to this Fabric renderer, JSI, and scroll analysis. Now the problem with this old architecture was that it was using a bridge-based architecture, which means continuous to and fro serialization was happening via JSON. So it might lead to some slow data transfer rate and unnecessary copying of data. Another drawback of this bridge-based architecture is that the communication was happening asynchronously, which means that events are not triggered if events are triggered, it is scheduled for its execution. Now let's imagine a situation where we have implemented a flat list with a data set as huge as 1000 list items, and we are continuously doing the scrolling. So each time a scroll event is triggered, its execution is actually uh, is, uh, is scheduled. It doesn't happen real time. So the disadvantage over there was that with the old architecture, that before the actual rendering happens, there was some white glitch or some UI glitch used to happen. But with this new architecture, we have now they have replaced the bridge based architecture with this new JSI based architecture. Now both synchronous and asynchronous communication tag can take place, which means that all the synchronous actions can be triggered and executed in real time. While drawing this comparison between the old and new architecture, we have built a very simple application. As you can see in the screen, it is a very simple application with a flat list implemented. Like the data set for comparison, we have kept the list items to be 1,000. To be honest, like with the new architecture and the old architecture, there was not a very significant change which we observed while doing the analysis. One thing is that during the scrolling with the new architecture, it was getting the scrolling effect was smoother as compared to the old architecture, which was glitchy kind of thing we are getting. So while building the application, you can see that uh, it will straight away say that running app name with some root ID tag. And with the new architecture, since we have enabled the new arc enabled value to true, so it will enable Fabric, which is the next generation view manager which it uses. So yeah, that's all about this Fabric renderer, GSI, and scroll analysis. So now going on to the lazy loading of turbo modules. So this is kind of a big advantage which we are getting over this new architecture. So earlier with the old architecture, what was happening, we have to preload everything. Like the native modules were getting preloaded. So that was increasing the app boot up time, which was very devastating for that. With the concept of turbo modules, we don't need to load the native modules beforehand. It behaves in a synchronous way in JavaScript and lazy load into memory, allowing the app to start faster. So with this new architecture, it requires interfaces specified in a type dialect of JavaScript. We have to create our own JavaScript specification that should be in a strongly typed language. Like if you are comfortable with TypeScript, you can create the specification in TypeScript, or if you want to go with JavaScript, you might have to integrate Flow with that. So CodeGen will use these specifications to generate code in strongly typed languages. So in the next slide, we'll show how we can create our own custom turbo module and integrate with the application. So yeah. So as I told that over this is a place where we are doing this new arc enable set to true. So it is inside this gradle.properties file. And this is the place where we are creating a JavaScript specification. JavaScript specification is nothing but you are creating the interface, what your turbo module should be looking like. The reference has been taken up from the React Native official documentation. We are creating a turbo module which is just doing some kind of a simple addition. It takes up two numbers and then sum the value and return it so that we can use it in the our application. So this is the place where we define the JavaScript specification. It should be in a strongly typed language, which means it should be written in TypeScript. So it should look like this. So this is the interface, and the proper implementations should be written. The proper implementations should be written in native code. Inside for Android, we have to write it inside Java, then subdirectory com folder. And we have to create our own file. We have to create one. We have to create the proper implementation of this, like what this interface should be doing. 1 second. So yeah, now we have to add this dependency. We have to add this module to our dependency, and we can straight away use it. We can import this dependency and we can start using this module. So this is a very straightforward example where we have showcased that how we can lazy load the turbo module. We don't need to load it beforehand. We just need to load it as and when required. So yeah. Next, going on to the next analysis, the app load time analysis. This analysis is very important, because if say if any for any mobile application developer or for any organization, the app load time should be very minimal, as it increases the user experiences. Let's say if your app is taking so much time, then you might end up losing your customers. So this app load time analysis is one of the major analysis part. So while doing the comparison, we have taken a very simple application built using a very fewer components, like loading spinner and text boxes and all. And the same application, we tried building it within the old architecture and the new architecture in place. So the app load time for old architecture for building this application was around 1.2 seconds, whereas for the new architecture it has decreased to 0.86 seconds. So we are getting a performance benefit using this new architecture in terms of app load time. So the possible reasons are, firstly, being the lazy loading of turbo modules. We don't need to preload everything, like location, Bluetooth, camera, and all those things. We don't need to. We have to just load it as and when required. And the second reason is that, as Shivraj was mentioning, that Herms will be set up as a default engine for any React Native application in the next React Native rollouts, for as a part of new architecture releases. So we have this Herms also in place, so that increases the app load time, that decreases the app load time. So yeah, now we have come to the conclusion of this talk, where we have seen that there are some disadvantages with this new architecture in terms of app load, app build time, and app storage. But as going with the official documentation, some experiments are going on, and by the end of this year, as they say, that 2022 will be the year of React Native new architecture. So by this end of this year, we can get some more clarity, like how it is performing on basis of storage and app build time. But as of now, these are the two parameters which are like being defeated in terms of comparison with the old architecture. But the with the new architecture, we are getting some benefits, like app load time has been decreased, and lazy loading of turbo modules, the fabric view manager, and all those things. So yeah, that's all. Thank you for this.